Yeah. Good evening, children. Good evening, online students.
Good evening.
Good evening.
Good evening.
Yeah, good evening, Aniruddhan, Aragamai, and Blessing. I've shared my screen. Visible, children?
Yes, ma'am.
Yeah. We have to continue from here, right? Yeah. So what do we have in the RHS? We have sine square A minus sine square B. But on the left-hand side, we also have cos. We have cos square B, cos square A, along with sine square A and sine square B. Left-hand side, we have sine and cos. But right-hand side, we have only sine, right? Right? So what should you do? Sine square A into, we don't want cos, right? RHS does not have cos. So cos square B can be written as 1 minus sine square B. Because cos square B, so 1 minus sine square B. Sine square B plus cos square B is equal to 1. Sine square B plus cos square B is equal to 1. So cos square B is equal to 1 minus sine square B. So 1 minus sine square B, close bracket, minus cos square A. 1 minus sine square A. 1 minus sine square A into sine square B. So next, what should we do? Multiply, right? Multiply and open the bracket. So sine square A into 1 is sine square A minus sine square A sine square B minus multiply this and this. It's like this 1 minus B into C. So C into 1 C, C into B minus BC. So sine square B into 1 sine square B sine square B, then minus into minus plus. Can you see minus into minus plus? See, you have to multiply this minus sign, the terms inside the bracket, and the sine square B. Where are you seeing, Niveda? Sine square B. We have to multiply sine square B, the terms in the bracket 1 minus sine square A, and the minus sign. So it's like you're multiplying minus sine square B into 1. Minus sine square B into 1 is minus sine square B. Then minus sine square B into minus sine square A. See the minus here, minus sine square B into minus sine square A. So minus into minus plus sine square A, sine square B. So they get cancelled, right? Sine square A minus sine square B, which is the RHS. Yeah, write down. Another 3 sessions we'll finish trigonometry. Then I'll just check what chapters are happening in your school and we'll do one of those. Actually, in the holidays, we'll catch up with your school. Like, I'll check like what chapters going on in your schools. Every school will be doing some different chapter. Yeah. So I'll just check and by May we'll catch up. You would have learned what is going on in school plus something new here. So from June all will be fine. Now also it's fine. The thing is maybe you're learning some other chapter in school, something else here. So you're not, there's some difficulty in balancing, but another 2 months, then it'll all be fine. Last class, you joined a few minutes late, right? Yeah, last class. Yeah, but you were able to follow? Okay. And what about the identities which you missed during the session? You wrote, or you took a screenshot and wrote. See, meeting recording is not shared always, but if you request, I'll share it to that student personally. Because if I put it in the group, then it becomes an advantage. Sometimes we just take a holiday. Okay, let me see the recording. She'll send the recording. So I don't share it in the group. But in case you take a holiday and you want the recording, I'll share it with you personally. All right. So that you should ask. You missed the class, but you didn't ask me. No, that only that you'll find in other reference books also. Explanation. Question and answers, there's so many reference books. You'll find resources, but explanation தானே வேணும். Done, children? Okay, next one. Yeah, go through the answer. I'll ask you. Go through how it's done, and then we'll do it. I'll do it. We'll do it together. I'll take your help and we'll do it together. All right? Yeah. See how it's done. Able to see, no? All right. Yeah. Done? You want some more time? Went through online students?
Yes, ma'am.
Okay. Yeah. is equal to 1. Now we have secant and tan, right? So we'll first open the bracket. And since it's secant and tan, they are related through the identity, right? Secant square A minus tan square A is 1. So we'll not change to sin and cos. We'll just do one step and see what happens. And then if needed, we'll change it to sin and cos. So when you open the bracket, this one, right? Minus. So this is what it looks like when we open the bracket, correct? Correct? Multiply. Okay. Now this secant, what's the rest? Oh, powerful. Okay. Now, what is the reciprocal of secant? 1 by x. So secant a to the power 4 minus into 1 by, yeah, minus 2 tan square a. Okay. So minus, what is sin a to the power 4 by cos a to the power 4? Yeah, sin a by cos a is tan a. So it will be tan a to the power 4 minus 2 tan square a. Now, this does not make up the identity a square minus 2ab plus b square because signs don't match. Now you can see it. Now this 2ab term should have secant and tan. No, the 2ab term should have secant and tan. So it has only tan. So this cannot be a square b square 2ab. No, because the signs also don't match. What do I mean by saying signs don't match? Because it should be a square plus 2ab plus b square. So all positive, or a square minus 2ab plus b square. So the a square b square terms are positive. The 2ab term can be positive or negative. The 2ab term can be positive or negative, but a square and b square terms are positive. But here, if you look at this as a square and this one as b square, it's negative, no? Supposing you can only look at this as a square and this one as b square. No, but it's minus b square. So it cannot be a square b square 2ab. Because, okay, if you look at this as minus 2ab, it should be plus b square. No, it's minus here. The middle term can be positive or negative. The a square and b square terms are positive. All right. If you have to show them, if you have to show that the terms are of the form a square, 2ab and b square, 2ab can be positive or negative, but a square and b square must be positive. So it's not possible. So next step, we'll write this as a difference of two squares. We'll write this as a difference of two squares. Okay, so secant square a the whole square minus tan square a the whole square minus 2 tan square a. So a square minus b square is a plus b into a minus b. So secant square a plus tan square a into secant square a minus tan square a minus 2 tan square a. Now secant square a plus tan square a is? No, secant square a plus tan square a. Secant square a minus tan square a is 1. This one is 1. So this into 1 only it is. You can just leave it, no? Because it's this one into 1, into 1. This one into 1. It's the same thing, secant square a plus tan square a. So just leave that and write minus 2 tan square a. Minus 2 tan square a. Correct? Why we didn't write 1? If it was plus or minus, if it was plus 1 or minus 1, we have to write. This is into 1. So when you multiply by 1, anyways, you're going to get the same thing, secant square a plus tan square a. So we then minus 2 tan square. Now like terms, secant square a, we have plus tan square a and minus 2 tan square a. So like terms, when you simplify, you get, I'll just do it here. You get secant square a minus tan square a, which is the, oh no, okay. Now secant square a minus tan square a is, all right, which is the RHS. All right. So maybe in my working, I've written this, exchange this. That's all. And maybe I've written this one first and then this one. Just check, don't get confused. Yeah, please write down. Yeah, Kamlani, what's the chapter going on in your school? Real numbers. You'll just start with real numbers, nothing else, huh? One minute. Real numbers. And this one number they finished. Now ongoing is real numbers. Confident? Polynomials going on. Yeah, Santanam. Okay. Yes, no? Amrita. Not yet started the portions. Your school? Real numbers. And then completed polynomials. That's okay. 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 So they're going the order. Okay. Same, huh? TNMS? Okay. Same, no? Only real numbers and polynomials. Okay. And your school? Real numbers, polynomials. Oh. Completed what? Oh. Hmm. Same, huh? Amrita Vidyalaya, you said they haven't started the portions for you? Started polynomials for you. No, you completed polynomial. That's all. Real numbers. Ah. Probability they do. Okay. Yeah, Blessing. Tell me the chapters completed in your school. Okay, Aniruddhan. Yeah, Blessing, you can say. Tell me the chapters that have been covered in your school. Okay, please text me later. Aniruddhan, please text me later as to what chapters have been completed in school. Same section, huh? Aragamai. Okay, state, most of you have finished real numbers. So state fundamental theorem of arithmetic. State the fundamental theorem of arithmetic. And the condition? Correct, you are right. 9 on 10. One mark for that 1 mark, you should say something else. Yeah, real numbers. I'm sorry. What is the fundamental theorem of arithmetic state? Exactly. Correct. So FTA states that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So like 15 is 3 into 5. 15 is a composite number. 15 is a composite number. It can be expressed as a product of primes, 3 into 5. 15 is a composite number, and so FTA states that every composite number can be expressed as a product of primes. So what is 15? 3 into 5. So somebody will say 5 into 3, but both are the same, right? So every composite number can be expressed as a product of primes. And the factorization is unique, meaning all of us will get the same answer. All of us will give us one answer only. You can't give different answers for this question. The answer unique means only one answer. And this factorization is unique apart from the order in which the prime factors occur. So a composite number can be 2 into 3 into 5 into 7, or 7 into 3 into 2 into 5. The order in which the prime factors occur may differ, but the prime factors will be the same, right? That is FTA. Okay. Now tell me the LCM of, what is the LCM of yeah, what's the LCM and HCF? LCM is x to the power y power 10, z also. Oh, okay. Then HCF. Very good. Very good. Common factors. Common factors x and y. Least powers. So 3 and 7. Correct. Very good. So LCM is write all the factors, not only common factors. Write all the factors with the highest power. For LCM, you should write all the factors you see with highest power. HCF, only common factors with the least power. So for LCM, I wrote LCM here. So LCM, so we see x, y, and z. So you should write x, y, and z. And for x, we have power 3 and power 4, highest power 4. For y, we have power 7 and power 10, highest power 10. Z, so you'll say that z is not here. You should write all the factors. But you can imagine a z with power 0 here, because z to the power 0 is 1, right? So you can imagine a z to the power 0 there. So between 0 and 1, the highest power is 1. Between 0 and 1, the highest power is 1. Yeah, so this is the LCM. For HCF, you should write only the common factors. Common factors only. So with the least power. So now you will say the upper Z2 common than na potukkalam. Z1 potukkongo. Least power enna. So that Z is not there anyways. See, if you say like put Z now, because it's common, X, Y, Z, you wrote Z there, so you put Z also because it's common. Okay, you can write Z, but with the least power, right? So least power 4 and 3, 3, 10 and 7, 7, 1 and 0, it will be Z to the power 0, which is 1. So it's this one. Okay, so can two numbers have 352 as their LCM and 6 as their HCF? Can two numbers have 352 as their LCM and 6 as their HCF? Can two numbers have 352 as LCM and 6 as HCF? Why? Correct. Correct. HCF is always a factor of the LCM. HCF should always be HCF is always a factor of the LCM. So the HCF is 6. 6 should be a factor of 352. So when you divide 6 5s are 30, 5 remains, 2 comes down, 6 how many times? 6 8s are right, 48. Correct? Yeah. So 4 is a remainder. 6 does not divide 352 exactly. 6 does not divide 352 exactly. So there cannot be, there are no two numbers which can have 352 as the LCM and 6 as the HCF. There can be two numbers which have 352 as LCM, or there are two numbers which have 6 as their HCF. But there exist no two numbers which have 352 as their LCM and 6 as their HCF. Both together, there exist no two numbers like that. Because the reason is the HCF should divide the LCM completely. The remainder should be 0. The remainder is not 0. So it's not possible. So there are no two numbers which can have 352 as their LCM and 6 as their HCF. Okay, yeah. I'm sorry. Yeah, now we can continue. Finish writing this one. Finish writing this one, all of you. Online students, done writing?
Yes, ma'am. Yes, ma'am.
Okay. Yeah. So 6 is 2 into 3, right? Will you put 2 inside or 3 inside?
3 inside.
2 inside. Cosecant square theta. Cosecant square theta, the whole cube. Now what is cosecant square theta? One plus cot square theta, the whole cube. Now you can expand this and you will get it. You can do it yourself. A plus b the whole cube is a cube plus b cube plus 3ab into a plus b. Finished? You completed the notes, is it? Which you missed last class? You finished writing? You'll take it from her, is it? Okay, so first 6 is 2 into 3. So cosecant square theta, the whole cubed. Okay. Now what can we do? That cosecant square theta, the whole cubed. Again, you can only multiply 2, 3, the 6 and write it as cosecant theta to the power 6. So you have to do some change, right? Otherwise, just with this, what can you do? Again, you'll have to multiply and go back to the earlier step. So you have to do something else here. So cosecant square theta is equal to 1 plus cot square theta. We choose to write that because you can see in the RHS we have cot. That's why. Now you will be like, why you're not writing cosecant square theta as 1 by sine square theta? We normally say, right, convert it to sine cos. No, that's because we can say in the RHS we see cot. See, we see cot in the RHS. So we don't write cosecant square theta as 1 by sine square theta. No, we write cosecant square theta as 1 plus cot square theta. So now we have a 3 here, the whole cubed. So we can expand it, a plus b, the whole cubed, right? And when you do so, you will get these terms. Can you see this is like something like 3a square b? Yeah. Okay. So this is the left hand side. Write it like this. Cosecant square theta is 1 plus cot square theta, the whole cubed. Now the identity is a plus b, the whole cubed is equal to a cubed plus b cubed plus 3ab into a plus b, where a is 1 and b is cot square theta, right? So you can see a cube plus this is b cube plus 3 into a into b into a plus b. So we get 1, then this term, and this when you multiply 3 cot square theta, look at the RHS, look at the RHS. Look at the RHS, so 1 plus cot square theta, you should put it back as cosecant square theta because that's what is in the RHS. Right one, this one cot theta to the power 6. When you multiply here, you will get 3 cot square theta. This one, when you multiply 3 into a into b, 3 into a into b is 3 cot square theta. And now 1 plus cot square theta, put it back as cosecant square theta. Because that's what you have here, 3 cot square theta, cosecant square theta. So this one is 3 into 1, 3 cot square theta. 3 cot square theta we have. But you should get 3 cot square theta, cosecant square theta. We have 3 cot square theta. You want cosecant square theta. So 1 plus cot square theta is replaced as cosecant square theta. And then I've just rearranged the terms like it is in the RHS. Is that fine? 1 cube, 1 we need to write because we have 1 here. And this one is cot theta to the power 6. We'll write it because we have it here. So we have got this term and this term. We have got these 2 terms. Now we need to just get one more term, 3 cot square theta, cosecant square theta. So we need to get just one more term. So this is that one more term. 3 into 1, 3 cot square theta. Yeah, we got 3 cot square theta. You should get cosecant square theta. So 1 plus cot square theta is written as cosecant square theta. Similar. Yeah. Tell me. First, put the 2 inside. So what's identity? A plus B the whole. What's A?
1.
Now keep looking at the RHS. 1, yeah, we have 1 plus tan theta to the power 6, yeah, we have tan theta to the power 6 plus 3 tan square theta, we got it, but it's secant square theta, so 1 plus tan square theta should be written as secant square theta. Now just rearrange the terms like it's in the RHS. We've got all the 3 terms, just rearrange. Yeah, write down. Aniruddhan, Blessy, and Aragamai, kindly ask. If I'm not clear anywhere, please ask me.
How do we draw this?
How? Rhombus.
Shape of rhombus.
Shape of a rhombus. Huh? You have to find the length of the diagonal. Perimeter. Side and one diagonal is given, is it? Yeah, or both the diagonals are given.
And we don't need arms, we just need the shape. Shape.
No worry.
Ma'am, this is diamond.
Okay. Yeah, like that only. When you rotate it, see, it's like this. When you rotate it, it's.
That's what we do, ma'am.
Idina.
We had a doubt.
No, when you draw it like this, no, you can. This is around the sea. Just rotate it and. Can you see from update parallel? Does it look like a diamond? Update parallel.
Thank
you. Done, children? Yeah. What's not there? Secant is not there. So tell me, what should we do? One plus? One plus? Tan square A. Yeah, multiply. Hmm. Yeah, write down. Yeah. You got the answer for the rhombus sum? No? Diagonals are given, right? And you have to find the perimeter. Should use Pythagoras theorem. Come here. Come fast. No, I'll tell you for different, some other numbers. What are the diagonals?
30 and 30.
Huh?
30, 34.
30 and 34. Okay, you do for this one. I'll give you some other values I'm saying. Okay, now supposing this diagonal is 20. Okay, so it will be 10 here, no, not 20. Okay, this is 16. So it will be 8 here and 8 here. And supposing this is 12. So it will be 6 here and 6 here. Now, in a rhombus, all these 4 triangles are right triangles. All the 4 are right triangles. So take up this right triangle. Take up this right triangle. To find the perimeter, you need to find the side, right? You need to find the length of a side. And we know all the 4 sides are equal in a rhombus. So this is a right triangle.
10.
Yeah, using Pythagoras theorem, this is 10. So now,
Everything is 10.
correct.
Now we
40.
should add.
All of them. Done, children? This one we've already done earlier, so just take, oh, okay. Write down along with me. This part we had an identity. This part we had an identity earlier. Finished? You got it? Not able to find the square root. Okay, next one.
Ma'am, can you show the 15th one?
Yeah,
ma'am?
sure. Yeah, sure. So first a
Thank
square
you.
minus, yeah, a square minus b square, a plus b into a minus b. So we have now secant square theta plus tan square theta, no? But look at the RHS, there is no secant square theta. In the RHS, there's no secant square theta. So how will you take it away? Secant square theta is 1 plus tan square theta. So tan square theta plus tan square theta is 2 tan square theta, 1 plus 2 tan square theta. Yeah, so this is, directly algebra. So how will you handle this? If you had a square, b square, and all that, how do you handle the situation? Sin square a cos square b plus cos square a sin square b plus cos square a cos square b plus sin square a sin square b. See, in standard 8, to factorize an expression, which has 4 terms. To factorize an expression which has 4 terms, what's that method we use? Grouping. Sometimes we rearrange the terms and group them, right? So that's what we're going to use here. So there are 4 terms. We'll group them in 2s. We'll take 2 terms, or we'll group in 2s, and between the 2 terms, whatever is common, we'll take it out. So now so this is 1 term. I'll just put a bracket. First term, second term, third term, fourth term. All the terms are separated by a plus sign. That's okay. Sign can be anything. There are 4 terms. Now, between the first and second term, is there anything common? Oh, the sin square b. Sorry, sin square. Yeah. Between the first and second term, is there anything common? No. Then you have to rearrange. If there's nothing common, you have to rearrange. If there was something common, also there should be something common between the third term and the fourth term. So there should be something common between the first and second, also something common between the third and fourth. If it is there, then you don't have to shuffle the terms. As it is, you can take out the common factor. But now there is nothing common between the first 2 terms. Also, there's nothing common between the last 2 terms. So you have to group. I'm sorry, rearrange. You will have to rearrange. Yeah. So which term do you want to write? 4 terms இருக்கு. இது first term. Second term எழுத முடியாது. அப்ப third or fourth எதை எழுதுறது இப்போ? Anything you can write. There should be something common. Fourth எழுதலாம். Third one எழுதலாம். Okay. Which one do you want me to write? Third one. Okay. So cos square a, cos square b. So we have to now write the second term, cos square a, sin square b, and the fourth term, sin square a, sin square b. So now between these 2 terms, what's common? Cos square b is common. So in the bracket, between these 2 terms, what's common? So in the bracket, that's all. Now cos square b, what is sin square a plus cos square a? 1. What's cos square a plus sin square a? 1. So it's into 1, cos square b into 1, cos square b. Sin square b into 1, sin square b. Now cos square b plus sin square b is 1. Now, but you remember in the 8th standard factorization, what we would do? In the 2 brackets, whatever is common, we'll write that once. You remember that? In the bracket, இப்ப நீங்க இப்படிதான் work பண்ணும். I'm just telling you in 8th standard, இந்த bracketலயும் என்ன இருக்கோ அதை தானே எழுதணும் ஒரு தாட்டி. You can do that also. You can do that. So whatever we have in the bracket, that should be common. In the 2 brackets, we have sin square a plus cos square a. We'll write that once. And then you remember, we'll write this and this together in another bracket. Cos square b plus sin square b. Then Cos square A plus sin square A is 1. Cos square B plus sin square B is 1. So 1. You can do it like this also. Write down. Should I clarify something? Okay. Done, all of you? Okay.
Yes, ma'am.
Yeah, good. Okay. This one is similar. Tell me. Fast, before I can write, you should raise me. Yeah. Next step. What should be written in the RHS? We have cot square A and cot square B. So don't disturb cot square A, cot square B. We don't want cosecant. Okay, so cot square A into 1 plus cot square B minus cosecant square A is 1 plus cot square A. Next. Multiply, open the bracket, minus, sorry, Oh, yeah, here. Yeah, right. Cot square. Correct? Correct? I don't. Done? Yeah. Okay, so here in the left hand side, we have secant and cosecant. In the right hand side, we have cot and tan. So from secant, we can get tan because, correct? From cosecant, we can get cot. So we don't have to change it to sine cos. We'll not change it to sine cos because we have secant, cosecant in the left hand side. And from secant, we can get tan, which is in the right hand side. From cosecant, you can get cot, which is in the right hand side, right? Okay. And okay, let me just write and tell you. Two secant square theta minus secant theta to the power 4 minus 2 cosecant square theta plus cosecant theta to the power 4. Now, if I rearrange like this, cosecant theta to the power 4 minus 2 cosecant square theta minus secant theta to the power 4 plus 2 secant square theta. And then cosecant theta. Okay. See, we just, if you look at this as a perfect square, if you look at this one as a perfect square, secant theta to the power 4, it's minus. See, if you want to show that an expression is of the form a square, b square, 2ab, we understood that a square and b square should be positive, and only the 2ab can be positive or negative, but a square and b square should always be positive. But here, if you look at this one as a square or b square, whatever, if you look at this as a perfect square, the sign is minus. Okay, so it should be a plus. But here we have cosecant theta to the power 4, which is positive. So we just write this one first because it's already with a positive sign. If you look at this as a perfect square and the sign is positive, so we'll write that first. And that should be followed by its relevant 2ab term, right? So which is the relevant 2ab term? Minus 2 cosecant square theta. For cosecant theta to the power 4, if you look at that as a square, okay, then the 2ab term can be minus 2 cosecant square theta. It's relevant. Okay, see, it does it look like 2AB? We'll discuss that later. But it goes with it, right? If you look at this one as a square, this can, of the terms available here, this only can be 2AB. Let me put it like that. Of the terms available here, only this can be 2AB. Now that B square term is not there. Okay, it's not there. Now again, in the next bracket, you can look at this as x square. And this as the 2xy term. Now I'm just saying x square and x square, 2xy, y square. A square, 2AB, B square. I'm just using x and y, that's all. So if you look at this as a perfect square, then the relevant 2AB term can be 2 secant square theta. But the sign, it's negative here. So what we do in the next step, we use a bracket. When we use a bracket, here, just collect the terms in a bracket. So for the first 2 terms, when we use a bracket, it's okay. First 2 terms, so you can just put a bracket like that. But for the 3rd term and the 4th term, when you put a bracket, the signs will change because, see, write the first term, second term. Now, before the 3rd term, there's a minus sign. You should write that minus only here. Before the 3rd term, whatever sign is that, that's what you should write down. First term and second term, we've just put it in a bracket. That's fine. After that, what is a sign? Minus. You should write that minus sign only. Now, you should write these 2 terms in a bracket. Now, minus into secant theta to the power 4 will be this 3rd term. Minus into minus is plus 2 secant square theta. Now, by using brackets, we have got the signs which we want. Now you can look at this one, the square term, it's positive. The square term is positive now. And we have a minus 2xy term or 2ab term. Okay. Now what is missing? The b square or the y square term is missing. In both the brackets, you have a square and 2ab. You have a square minus 2a, but you have a square minus 2ab. You don't have plus b square. And if cosecant square theta is your a, and this is your 2ab term, 2 cosecant square theta is the 2ab term. What is b then? 1. B is 1 because this is 2ab, but 2 into this one is a. That means into b should be 1. If this is a square, if this one is a square, then the a term is cosecant square theta. Then what is this is a? This is a. Then what is 2ab? 2 into cosecant square theta. That itself is a 2ab term. That means b is 1. B is 1. Similarly here, what will be the a term? What will be the a term here? Secant square theta. Secant square theta. What's the 2ab term? Minus 2 into secant square theta into 1. So the b square term or the y square term is 1. 1 square, 1. So what we do is, in the next step, what we do, we write what one you want? You want plus 1 or minus 1? Plus 1. Just write it. Okay. You should now tell me, see here. What have you done in the first bracket? You put a plus 1, right? If you write a plus 1, you should write a minus 1, no? If you put a plus 1, you should write a minus 1. Only then plus 1 minus 1 is 0 and you're not changing the value of the expression. So we put a plus 1 here. This one looks like plus 1, but plus into minus is minus only. So it's actually minus 1 only. So though you have, put plus 1 in both the brackets, it's plus 1 in the first bracket. And when you open the second bracket, minus into plus minus 1. So it's actually plus 1 minus 1, which is 0. So this is the next step. You just add 1 in both the brackets. So here we have plus 1. Here this minus into plus minus 1. So plus 1 minus 1 is 0. So you have not done any change. Now show that the three terms in the two brackets are of the form a the whole square minus 2 into a into b plus b the whole square. So what is here? Cosecant square theta. And here 1. So in the bracket into minus 2ab. So minus 2 into a. This is a into b. Correct? Yeah. Do the same thing. The second bracket. Write the a square term minus 2 into a into b and plus b square. So secant square theta, then 1 secant square theta into 1. 2ab. 2 secant square theta into b, which is 1. So now in both the brackets we have three terms which are of the form a square minus 2ab plus b square. So can be written as a minus b the whole square. A is cosecant square theta, because it's minus 2ab, so it is a minus b the whole square. It's a square minus 2ab plus b square, so a minus b the whole square. So this is the result of the first bracket. Then minus, the connecting sign is minus. Okay. Second bracket also is of the form a square minus 2ab plus b square. So it is a minus b the whole square. See, if you want, you can put a 1 square. You need b square, which is 1 square, but 1 square is 1. So I've just written 1 in both the brackets. Now, what is cosecant square theta minus 1? Cosecant square theta minus 1 is cot square theta. Cot square theta, the whole square. Minus, what is secant square theta minus 1? Tan square theta, the whole square. So this is, yeah, which is the RHS. All right, write down. What are you writing in his book, Navneet? Did you get the answer for the rhombus question? That's what I asked you, Oprah.
Yeah.
Get your book here. Is the question to find the perimeter or area? Come here. No, get your textbook. That book I need. Which one?
This one first. Fine.
So 15 will be 225 and 34 will be 289. Yeah.
17. So
Idea
5
of X square. Yeah, correct.
514. So I
And
wrote.
the numbers tappa kutirukanga. I'll give
So I
you.
wrote 514 into 4 perimeter.
No, you take it as I'll tell you. Take one diagonal as
And can we take the 8 as I mean
take one. Yeah, take one diagonal as
8.
yeah. You can take this 16, not 8. 16.
But like
You can take one as 30. The other one is 60.
15 and 8, 17. Yeah.
50.
8,
Yeah.
15, 17.
Correct. Yeah. You can take this one as, this one let it be 30. Take this one as 16, 1, 6, and do it in
Okay. Can do the exponents.
Yeah. Yeah. Done, children? Finish writing, online students?
Yes, ma'am.
Okay. Yeah. Just give the heading standard questions. We have more identities to prove. I'm just switching to a different part of trigonometry so that it doesn't become boring. Yeah. Just give the heading standard questions. Because if they're asked, it will be like this only without any change. Yeah. Okay. So you'll have to show that sine theta is equal to p square minus 1 by p square plus 1. So show that sine theta is equal to p square minus 1 by p square plus 1. So read it like this. Show that p square minus 1 by p square plus 1 is equal to sine theta. Read it like this. The question can be given like this also, like as it is given here. You read it like, show that p square minus 1 by p square plus 1 is equal to sine theta. Because we are given an expression for p, right? What is p? Secant theta plus tan theta. We are given that p is secant theta plus tan theta. So show that p square minus 1, p is given to us. So show that p square minus 1 by p square plus 1 is equal to sine theta. So we will work p square minus 1 by p square plus 1 and we'll show that the result is equal to sine theta. I'm saying don't work with sine theta. Don't take sine theta and try to get p square minus 1 by p square plus 1. Sine theta is a simplest form, right? So what will you do with that? So don't try to work with sine theta. Read it the other way. It may be given like this, but you read it the other way. Show that p square minus 1 by p square plus 1 is equal to sine theta. And we are given the expression for p. Okay. So now p square minus 1 by p square plus 1 is equal to, what is p? Secant theta plus tan theta. P is this one, secant theta plus tan theta square minus 1 by secant theta plus tan theta, the whole square, plus. Now let's expand, because when we expand, no, we'll get secant square theta, tan square theta. So we can use identities. Now it is only secant theta and tan theta. We'll expand. We'll not do a square minus b square is a plus b into a minus b, because when we do that, the numerator is like a square minus b square, right? The numerator is like a square minus b square, secant theta plus tan theta, the whole square minus 1 square. But if you write it as a plus b into a minus b, you will get secant theta and tan theta only. You will not get power 2. But okay, so what is a plus b? This is a plus b plus 1 into this is a minus b. If we had no choice, we'll do this, but we have a choice. Instead of doing this, if we expand the a plus b the whole square, then what will you get? You'll get secant square theta, tan square theta. So that's more helpful, because secant square theta, tan square theta. So you can use identities. When the power is 2, I'm saying. When the power is 2, it's more helpful. Yeah, so we want power 2. So we'll go with expanding. We'll expand. We'll expand, so we'll get power 2. We'll get secant square theta, tan square theta. So we can maybe use identities also again. So a plus b the whole square is a square plus b square plus 2ab, 2 secant theta, tan theta. And that minus 1, which is outside, divided by, again, same thing, no? A square plus b square plus 2ab, 2 secant theta, tan theta, plus 1. So we expanded. So now we've got secant square theta and all that. Now, since we have a minus 1 and plus 1 here, try to group the secant square theta, tan square theta, these in their moonala edan render. And see, I'm just ticking. Now, like, okay, see, you know, secant 1 plus tan square theta, secant square theta, right? So tell me, how can we replace in the numerator? Will you take secant square theta minus 1 or tan square theta minus 1? And in the denominator, will you take secant square theta plus 1 or will you take tan square theta plus 1? No, let me make myself more clear. In the numerator, we have secant square theta plus tan square theta, right? But that's not 1. Secant square theta minus tan square theta is 1. Secant square theta plus tan square theta is not 1. Okay. Okay, so we can secant square theta plus tan square theta, we cannot do anything. In the end, in the numerator, we have a minus 1, right? So now tell me, will this give you something or this give you something in the numerator? And in the denominator, will this give you something or this give you something? And the one in the numerator, tan square theta minus 1, the numerator. No. First, am I clear? Anugrah is like, no, actually you're not clear. No, am I clear? Yeah. Numeratorல இந்த options இருக்கு. Numeratorல வந்து secant square theta plus tan square theta is not 1. Okay, இங்க minus 1 இருக்கு, இங்க plus 1 இருக்கா? So numeratorல நீங்க secant square theta minus 1 group பண்ண போறீங்களா? இல்ல tan square theta minus 1. Denominatorல is it going to be secant square theta plus 1 or tan square theta plus 1? which will help you to replace using the identity secant square theta minus tan square theta is 1. Yeah, in the numerator, it should be secant square theta minus 1. That is tan square theta. So just group the secant square theta and minus 1, group that. Then write the rest of the terms as it is. Write the rest of the terms as it is. Onnola rearranging pandrom. Secant square theta minus 1. Then we have written all the other terms as it is. In the denominator, tan square theta plus 1. Correct. So secant square theta plus tan square theta. With this tan square theta, we'll take the plus 1. Plus 2 secant theta tan theta. Now remember, you cannot cancel these two. Nadula plus sign irukku. We cannot cancel 2 secant theta tan theta, 2 secant theta tan theta. We cannot. Okay, so now secant square theta minus 1 is tan square theta and plus tan square theta plus 2 secant theta tan theta divided by here tan square theta plus 1. So secant square theta plus secant square theta plus 2 secant theta tan theta. Correct? So it will be 2 tan square theta, because tan square theta plus tan square theta is 2 tan square theta plus 2 secant theta tan theta divided by 2 secant square theta plus 2 secant theta tan theta. Now what's common? What's common in the numerator? 2 tan theta is common. 2 tan theta is common. So tan theta plus secant theta. Tan theta plus secant theta divided by 2 secant theta is common. Secant theta plus tan theta. Now they'll get cancelled, no? Bracket. Secant theta plus tan theta, secant theta plus tan theta. 2. Now what is tan theta? Sin theta by cos theta. Now what is the secant theta? Secant theta is like, it's like this, no? It's like divided by secant theta like this, right? Tan is sine by cos. Tan is sine by cos divided by secant theta. Tan theta is sin theta by cos theta divided by secant theta. What is secant theta? 1 by cos. It will be divided by 1 by cos theta. So next step it will become into cos theta by 1. So that cos and cos will get cancelled and sin theta is the result. Yeah, write down. Okay. Okay, what am I going to do? After? Anytime is fine.
From but morning and sleep.
Yeah, that's why I asked you what time. After 11, after 11, anytime after 11. Yeah. Hmm. Yeah, see. Finished? Yeah. Yeah, try a similar one. Completed this one, all of you? Is this one? Okay. You watched all the videos of trigonometry? You were not in town, or you didn't want to come because school reopened at home? Huh? School ke? இல்ல இல்ல நீ ஊர்ல இல்லன்னு வரலையா இவ்வளவு நாள்? இல்ல ஸ்கூல் திறந்துட்டோம் போய்க்கலாம்னா டியூஷனுக்கு. ஸ்கூலே திறக்கல அதுக்குள்ள என்ன டியூஷன் வரலையா? Thursday first நல்ல நாள் பார்த்தீங்க. அப்புறம் Thursday வரல. No, why you didn't attend the classes from the beginning is my question. You finished your exams on March 6th, right? Yeah. அதுதான் கேட்டேன். Native place. Okay. When did you return? Oh. Okay, then Thursday rest எடுத்தீங்க கொஞ்சம். Thursday your father was not there to drop you, so அப்ப ஆன்லைன் அட்டென்ட் பண்ணிருக்கலாமே. அவருக்கு என்னன்னா ஸ்கூல்ல திறக்கல, அப்புறம் என்ன டியூஷன் போறது? மறந்துட்டீங்களா? ஓ ஆன்லைன் இருக்குன்னு மறந்துட்டீங்க. போன் அப்ப அதுதான். See? Yeah, children, please do this one. Similar to the earlier one. Do this and you will feel nice. If you do this correctly, you will feel very nice and confident. You can refer to the previous working if you want. There it was secant tan, here it is cosecant cot, that's all. Why work? Hold on. Finish, Kamalika? Okay. See this theta minus 1 is what? Right, one by in release it. You have to make that information. Seeking we don't have time to revise or the not time to revise and practice and do after the whole we are not taking this one. And actually inside the not now
Ma'am, finished, ma'am.
yeah. Where or online sessions be available work. So now you work on I can understand what it is. Last time the online session announcement we already did answers. But I don't see the same students as the individuals. Majority of Almost all. Parts to people, parts to people problem. In the parts to people, part because of problem. The step with the one community design. Here from there are two terms, right? Central to the parts by three part, the bigger part is two part, the pharmacy. How can I write it? To make it go to one. Two part, into what the parts were taken. Part one, two, three, four, you always do that. We just said, we first come so that's what we always do that. What you have to understand. Until the relevant term except that you just this is there, 9 we want to be angry. Subsequent. Arts they become unseen. Proceedings will become unseen. Proceedings will become items starts by the country. Arts will become not the group proceedings will become plus one. Parts will become plus one in denominator. Listen, in a group only that's the content. Yeah, please check. Okay, please check. All of you have got it right. Most of you have got it right. For the others, I'll send the picture on WhatsApp. Please check. Yeah, online students, tell me. Able to get this?
Yes, ma'am.
Okay. Anirudhan and Aragamai. Cos theta. Got it?
Yes, ma'am.
Okay. Yeah, open your statistics book, all of you. Last class I gave question from median, no? Okay, do the second one. Try the second question. Find mode for the following less than cumulative frequency distribution. You can just revise today's classwork, or you cannot try this. You can just revise today's classwork, or have you completed the notes in your book, trigonometry? No. The pre-work which I given? இதுமே இன்னும் ஆரம்பிக்கல, இனிமேதான் எல்லாமே பண்ணணும். எழுதலையா இன்னும்? You stay back after the class. You also stay back. I'll tell you what you have to do. Question number 2, test. So as if the values given with the less than a symbol, they are the lower limits or upper limits? Lower limits or upper limits? Upper limits. With the less than symbol, what you see are the upper limits. Upper limits. So what are the class intervals? They are the upper limits. So 140 is the first upper limit. So it will be 135 to 140, 140 to 145. Very good. Yeah. Then how do you write? Are these numbers frequencies 4, 11, 29? Are they frequencies or cumulative frequencies? The cumulative frequencies. Because class intervals irundha frequency. Less than, more than irundha, adella cumulative frequency. See, this distribution is okay. Fine, I'll tell you that later. So these are the cumulative frequencies. So how do you find the frequencies? Write the first one as it is and then keep subtracting. Write the first one as it is, keep subtracting. Yeah. If you've all done that. You change the formula. You knew you have to subtract. You are already you also 3. Incorrect. Yeah. How to find the whichever you should find the highest you should look for the highest frequency. The corresponding class interval is the modal class interval. The class interval corresponding to the highest frequency. Yeah, Aniruddhan, read out your class intervals and frequencies. Or Blessy, Aniruddhan and Anagamai, send a picture of your work, the 3 of you.
Ma'am, 1 minute, ma'am. I cannot send it by this
Okay,
tab.
Blessy,
Because...
Blessy. Yeah,
Ma'am,
Blessy
can I
can
tell,
send. Blessy and Anagamai, please send your pictures. Yeah.
Ma'am, I cannot send, ma'am. My parents are attending in the phone.
Oh. Okay, read out your class intervals.
4, 7, 18, 11, 6, 5, 0. Frequencies.
Okay, class intervals, correct. Frequencies are right. Class intervals?
135 to 140, 140 to 145,
correct. Very good. Thank you. Thank you, Blessy. Yeah. Aniruddhan, class intervals?
ma'am, 135 to 140, 140 to 145, 145 to 150.
Okay, 1 minute. So these numbers are the lower limits or upper limits? The numbers you see in the table, 140, 145, 150, they are the upper limits or lower limits?
Upper limits, ma'am.
Upper limits. Okay, read your frequencies.
Ma'am, I wrote the number of girls as a frequency, ma'am.
அங்க என்ன இருக்கும் அதே எழுதியாச்சா?
Yes, ma'am.
Wrong. You're wrong. Got the answer? Very good. Anirudhan, this table is called a cumulative frequency distribution or cumulative frequency table. Okay. These are the less than values and these are their corresponding cumulative frequencies. See, the table itself is called a cumulative frequency table. Why is it called a cumulative frequency table? Because you don't have class intervals. You have values less than 140, less than 145. Whenever you have the less than or the more than values, when you have the less than or more than values, the table is called a cumulative frequency table. And so the numbers which are given here, these are cumulative frequencies. They're not frequencies. See, it's very simple to remember. If you have in the table, if you have class interval and number of students, then these are the frequencies. But in the table, if you have less than values or more than values, and you have number of students, then these are the cumulative frequencies. In the table, if you have class intervals, that is 10 to 20, 20 to 30. If you have class intervals like this and some numbers here, number of under the heading, number of students, you have numbers here. These numbers are frequencies. If you have class intervals, these numbers are frequencies. But if you have less than or more than values, and the second column is number of students, same heading, no, here also number of students, here also number of students. If number of students column is given with the class intervals, then these are frequencies. If the number of students column is given with the less than or more than values, then these numbers are cumulative frequencies. Am I clear?
Yes, ma'am.
So since this one, in this table, we have less than values. That means these are cumulative frequencies. That's why the table itself is called a less than cumulative frequency table. The name of this table is less than cumulative frequency table. So what do? You should write the first frequency as it is and then keep subtracting. You must write the first frequency as it is 4. Then 11 minus 4, 7. 29 minus 11, whatever. 40 minus 29. 46 minus 40. And 51 minus 46. These are the these are the frequencies. Okay, who's got the answer? Bhavishya. 1. Check. No, maybe sometimes I go wrong in typing. Let me see. See if this is mode, no? Why have I done n by 2? Just ignore it. Sometimes, like mode only. No, yeah. Modal class interval is ignore this. Which is the modal class interval? Is this correct? Then see where you or I have gone wrong. 4, 7, 18, 11, 6, 5. The highest frequency is? Sorry? -6 minus 7 is 18. I'm checking it myself. Sorry? Ah, okay. Then my answer. No, because she has a different answer. I'm just checking. Okay. 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 18, 7, 11, and H is 5. So plus 18 F1 minus F0 by 2 F1 minus F0 minus F2 into H. 145 plus 11 into 5 by 18. 55 by 18. 55 by 18. Yeah. So there's no mistake here. So what you see on the slide is the right answer. Thank you. You don't have to write the CF column also. You don't have to write the CF column. So, what's your name? Anugrah, how do you find the modal class interval? The class interval pertaining to the, the class interval corresponding to the highest frequency, not highest cumulative frequency, highest frequency is the modal class interval. And last class, some of us missed L plus. Now I saw a book where there is no into H. So we are forgetting. Okay, please, it is L plus, lower limit plus, and don't forget the H, into H. Okay. Okay, how many of you got values till here correct? Till here, how many of you were right? Okay. Okay, no, how many of you got the final answer correct? Only Swati. Okay.
Ma'am,
1 second. Bless you also? Very good.
Yes, ma'am.
Okay, very good. Yeah, then how many of you got till here? No? Why? Ah. How many got? You all got it. Renu? You got it till here, right? You've found the values? No? Oh, okay. Girls? Stay back, no? You three and you both also stay back. I'll ask you what. You? You got H. No, but these values you got it right? Okay. What about Aniruddhan and Aragamai? Yeah? Okay, fine. So how do you, let me just make it fast. What is the name of this distribution? See, there are only two types of tables. There are only two types of tables. Cumulative frequency table, that's all. There are only two types of tables or two types of distributions. Frequency table or frequency distribution, cumulative frequency table or cumulative frequency distribution, that's all. Now in this cumulative frequency distribution, we have two types, less than, more than. Less than cumulative frequency table, more than cumulative frequency table. So in one column, if you have less than values or more than values, the second column is cumulative frequency column only, whatever be the heading. Heading can be frequency, number of students, whatever is the heading. If one column is the less than or the more than column, that is the less than values or more than values, the next column is the cumulative frequency column only. Because if you have less than or more than values, the table itself is a cumulative frequency table. So the numbers are cumulative frequencies. Got that? The other type of table is frequency table. In frequency table, you will have class intervals. You will not have less than, more than. In frequency table, you will have class intervals. And the numbers you have with the class intervals are frequencies only. They cannot be cumulative frequencies. Even if by mistake it's given CF, don't go by the, Don't see the heading at all. Whatever be there, if it is class intervals, the number of frequencies only. If it is less than more than values, then in the next column, the numbers are cumulative frequencies only. And go home and meaning practice as to how to prepare, get the frequencies. So what you have with the less than values are the upper limits. I also told you one thing, where the frequency or cumulative frequency is zeros, strike it off. Strike it off, I told you. So with the less than values, what you have? The upper limits. With the less than values, upper limits. With the more than values, lower limits. If the cumulative frequency is zero, just strike off that row. So you'll get the class intervals easily. Then what you have are the cumulative frequencies. If it is in the ascending order, if it's big to, if it's in the ascending order, meaning small to big, write the first one as it is and then keep subtracting. That is in the less than table. In the less than tables, in the less than table, you will have the numbers in the ascending order, like 4, 11, 29, 40, like this it will be. In the more than table, it will be the other way. It will be 51, 46, 40, 29, 11, and 4. If it is a more than cumulative frequency table, the cumulative frequencies will be in the descending order, big to small. In the less than table, it will be from small to big. So here what you should do, you should write the first frequency as it is and keep subtracting. Here you should subtract and write the last frequency as it is. You understand? If it's in the ascending order, that is small to big, 4, 11, 29, 40, small to big, write the first one as it is and then subtract. If it is in the descending order, big to small, don't write the big value as it is. 51 abde podakudadu. Subtract, keep subtracting, write the last one as it is. So எப்பவுமே the smallest value தான் அப்படியே போடணும். So smallest value எங்க இருக்கு? 4 ஆ 51 ஆ 4. அப்ப 4 அப்படியே போட்டுறணும். அப்புறம் subtract பண்ணி எழுதணும். இப்ப இப்படி இருந்தா 51ல இருந்து இப்படி இருந்தாக்க, which is the smallest value? 4. Should write that as it is. So keep subtracting. So here you should subtract and then you should subtract and write the last one as it is. So these things you must remember, and before anything you should remember the formula. Okay, so that one class which I couldn't make last week, that's because this is March and exams. For some school I had to make a class on Thursday because they had their exam. That is why I couldn't make the class on Thursday. I canceled one class, right? So I'll be compensating that class next week, but it will be an online class. Compensation classes mostly because Monday to Saturday I have classes, so I can't make a physical class for compensation. So it will be online. If possible, I can make a physical class, but it's not possible. So it will be an online class. So Tuesday evening, are you all available on Tuesday evening? Tuesday or Wednesday evening it will be. Wednesday you have some other class? Okay, you see, but that I can't say. One of the days normally Wednesdays you don't attend, no? Okay, so mostly not Monday. So Tuesday or Wednesday, that is before the Thursday's class. If I'm not able to make it before the Thursday's class, maybe next Friday. But next week I'll compensate for that class. It will be an online class, so check WhatsApp for the message. All right, so it'll be online. All of you must take it up. All right, children. So that's it for today's session. Thank you so much. Online children, have you? Yeah, you should. You didn't tell me. Yeah, you people can leave. Good night. You three wait and you both wait.